Hey students, welcome back to the unit on the area of polygons and the lesson on trigonometry and area. This is video number 2. So if you haven't watched video number 1, you probably want to do that because we're doing a bit of review of trigonometry. And what we're going to do in this video is start working with the area of polygons again. Okay, but this time we're going to really make it as challenging as we possibly can. So let's do a quick review on trigonometry concepts. We have, remember the trigonometry ratios with sine and cosine and tangent. Sine being the opposite over the hypotenuse, cosine being the adjacent leg over the hypotenuse, tangent being the opposite over the adjacent, and remember Chief SOHCAHTOA. And so we're going to recall that along with a couple other things from our notes on regular polygons. So a couple things about regular polygons to review: that a circle is 360 degrees around, that when we have two consecutive radii, we have a vertex angle, and we can find that vertex angle by dividing 360 by the number of sides. And we also know that if we have a regular polygon, we can make what I called a pop-out triangle, and we can easily find the angle of that pop-out triangle by taking half of the vertex angle. Because in that pop-out triangle, we will have a radius, and we will have the apothem, and we will have half of the side of the regular polygon. And we will definitely get more into that into the new video. But this is all from previous video on area of regular polygons. So if you haven't mastered that yet from Chapter 10, Section 3, or the videos on regular area of regular polygons, you probably want to get back to that because I took it easy on you then. Now we're going to make it a little bit more challenging. So we're going to use all of that and get busy, right? So remembering also that the formula for the area of a regular polygon is 1/2 the apothem times perimeter. So that was quite convenient. So here's the question. We're going to jump right into something rather challenging. What is the area of a regular nonagon with 10 centimeter sides? So we got regular, so we know this formula applies. All right, so we know it's regular, we know this formula applies. We have, all we're given is 10 centimeter sides, dagnabbit. But what can we use with that information? We actually know the thing. We know a thing. We know the perimeter. Okay, so we know perimeter in this case. The perimeter is quite simple to find because we're dealing with a nonagon. Now, do you remember what nonagon means? Okay, so hopefully you remember nonagon means we have 9 sides. So if we have 9 sides and each side is 10 centimeters, we know our perimeter is going to be 9 times 10 or 90 centimeter sides. Okay, so we know our perimeter. The challenge here is that we don't know the apothem. Okay, so the challenge here is we don't know the apothem. This is what we need. Okay, so we need our apothem from the diagram. So how does this work? Again, I use the pop-out triangle. So I'm going to pop out a right triangle and then work with it. And I know that in this right triangle, I am going to need the apothem. That's all I know right now. Okay, so what can I figure out to find out all this stuff? Actually, I know something else. If I have a pop-out triangle, not only do I know I need the apothem, I actually know the length of the short leg of this triangle. Okay, so the length of the shorter leg is not 10, but it's half of 10. Right? In this regular polygon, if the whole thing is 10, that means the short leg is 5. Okay, so in this case, we know that distance in that shorter leg is 5. Now, is this a 30, 60, 90 triangle? That's the question. The answer is I don't know. So how are we going to find out? We need to find out what our angle measure is that we're dealing with here. So how are we going to find out the angle measure there? Well, we need to find out the entire vertex angle. If we knew the entire vertex angle, we would know the angle for the pop-out triangle. So how do we find the vertex angle? Remember how we find the vertex angle? We divide 360 by the number of sides. Okay, so remember what we had talked about before from the notes. Okay, how do we find the degree measure of the vertex angle? The 360 divided by the number of sides. Okay, so our vertex angle in this case is 360 divided by 9, which is 40 degrees. So the vertex angle itself is 40 degrees. What then is the measure of this angle in our pop-out triangle? It's going to be half of 40, or 20. So we know that the degree measure in question is 20. And the question becomes now, well, how can I figure out the rest of the information here? I need the apothem. If I know this is 5 and this is the 20-degree angle, what do I do? Well, we have to re-invoke Chief SOHCAHTOA. We have to remember how our trigonometric ratios work. We have an angle here at 20 degrees. There's a trig ratio for that angle that deals with the side lengths, right? So which trig ratio deals with these two segment lengths in our case? And hopefully you realize from that angle, 5 is opposite and the apothem is adjacent. So we have the opposite and the adjacent. So if we're dealing with the TOA part of Chief SOHCAHTOA, we have the opposite and the adjacent, so we're going to be dealing with the tangent. Now how does this work? Okay, so it works by setting up an equation. We can now set up an equation. We can work with the tangent of 20 degrees. If we're to look at this angle and say, hey, we're going to take the tangent of that angle, the tangent of 20 degrees is going to be the opposite leg over the adjacent leg. So the tangent of 20 is going to be 5 over our apothem. All right, so we set up our equation, and now what we can do is solve this equation. Now, I don't know if you remember how this works from Chapter 8, but you should review Chapter 8, the videos on trig. But how does this work? Well, we can multiply both sides by a and then divide by the tangent of 20. I don't know if you remember how that works. We're going to multiply both sides by a and then divide by the tangent of 20. But this was the shortcut on finding out what that variable would be. Okay, so we now have the apothem. So do we punch in our numbers here? We can. We know our perimeter was 90. We know our apothem is whatever this comes out to be in the calculator. And this is what I'm going to caution you about. I want you to round at the very end. Save rounding for last. And that's going to be, it's going to make things look kind of tricky, but I'm going to teach you how to use the calculator. Okay, so we're going to save rounding for last. And things are going to look crazy, but that's how we'll use the calculator. So the formula for area is 1/2 the apothem times the perimeter, which means we have 1/2 times, what was our apothem? It was 5 over the tangent of 20. And then that would be multiplied by the perimeter of 90. The rest is calculator work. We are seriously done. We have answered the question about the area. Okay, so we are done. All we need to do now is a bunch of calculator work. So how am I going to do this? I'm actually going to enter my most complicated thing first. So 5 over the tangent of 20. That's what I'm going to enter in my calculator first. So I have my calculator. I'll have 5 divided by 20 tan equals. So this is my apothem, right? That 13.7373 blah, 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 blah. That is my apothem. Okay, but I'm not going to do anything in the calculator. I'm going to keep going. Now, this is what I have just found here. So the second thing I'm going to do is multiply by 90. So I multiply by 90. There's my equal sign. And then the third thing I'm going to do is divide by 2. So when I have that monstrous value in there, I can take everything I have, multiply it by 90, and then divide by 2. So I have my apothem, I have my perimeter, divided by 2, and it turns out to be that my area is 618.18 and then centimeters squared. Okay, so that would be the area of that regular nonagon. Now, it all depends. This didn't say round to the nearest whatever. So it could be a whole bunch of things. It could be 618 centimeters squared. It could be 620 centimeters squared. It could be 618.2 centimeters squared. It all depends on the question. So we have to be cautious and keep in mind when we are working with area and we're working with rounding that that you never know what the answer will be. And so it's very important that we read directions, okay? So there's our answer, okay? So that's how it works. Let's keep going. And remember, we're going to save rounding for last. So let's do a few more of these. I'm going to go as fast as I can without trying to lose you, okay? So here's another example. We have, what is the area of a regular pentagon with 4-inch sides? Round our answer to the nearest square inch. This is how this works. We have regular area. That means we are working with 1/2 the apothem times the perimeter. We have a pentagon with 4-inch sides, which means we know what the perimeter is. So hopefully you are calculating perimeter right now. Pentagon is 5 sides. 5 times 4 is 20 inches. Okay. So now what is going to happen? How is it that we can find the apothem? Do I need to draw a pentagon in order to make my pop-out triangle? And the answer is not really. I'm going to go ahead and just make a pop-out triangle. Because in the pop-out triangle, how does this work? Well, we have 4-inch sides, and we know this, the smaller leg, is the half side. And the smaller leg is going to be 2. And what are we looking for? Okay, we have the smaller leg is going to be 2, half the side. We are looking for the apothem. That's what we're looking for. So what's the missing piece of information? The missing piece of information is the angle in my pop-out triangle. Okay, so that's what I'm missing, because I can use tangent now, right? The tangent of that angle is equal to the opposite over the adjacent. We know the opposite side is 2 inches. And I'll make in inches there so we don't get confused on where it came from. So all we need to do now is figure out what's the angle measure. We need our vertex angle. So the vertex angle is found 360 divided by the number of sides, pentagon, 5. So that gives us a result of 72. So we know the vertex angle is 72 degrees, but that is not what this is. We have to divide that by 2, right? Because the apothem bisects the vertex angle. So when we divide this by 2, we have 36 degrees. So all of that just occurred with review stuff. Everything that we've talked about is review from both Chapter 8 and Chapter 10, Section 3, when we're talking about area of regular polygons. So we have everything we need right now. All we have to do is use a little bit of trigonometry to find out what the apothem is. So we have our angle, we have an opposite side, and an adjacent side. So once again, we have opposite and adjacent. That's TOA. Okay, SOHCAHTOA, Chief SOHCAHTOA. So we can set up our equation. We can say that the tangent of 36 degrees, the tangent of this angle is going to be 2 over our apothem. And now if we're going to solve our equation, we will solve for multiplying both sides by the apothem and then dividing by the tangent of 36. And we now have our apothem. And remember, we're saving rounding for last. Okay, save rounding for the end. So we're going to save rounding until the very end. Okay, so make sure we remember that's what's happening. So we go back to the area is found 1/2 of the apothem times the perimeter. We already found the perimeter. So it's 1/2 of the apothem. 2 over the tangent of 36 times the perimeter. Remember, we found the perimeter of 20. And so when I use the calculator, I'm going to use it in order. The first thing I will do is find the apothem, and then I will multiply by 20, and then I will divide by 2. So let's do that all in one big swoop of the calculator. So 2 divided by 36 tangent equals, and so we have our figure there. That's just the apothem. And we're going to multiply that by 20. And then we have our value here, and then we're going to divide that by 2. And so we end up with 27.53, or however the question asks for. It does ask for something. It says round your answer to the nearest square inch. And what is the nearest square inch, by the way? The square inch means it's the nearest whole number. So if we're rounding 27.5 to the nearest whole number, we will actually be rounding to 28. Okay, so that's going to be kind of important. We're rounding that to the nearest whole number, and that is 28. Okay, so we now found our answer to be 28 square inches. And that is how that works. All right. So let's work on another example, and then we'll finish. We'll actually do 2 more. You know what? I'm going to save this for the last one. We're going to do, since these 2 are a little bit more complicated, we'll save this for video 3. I'm going to stop for now. It says long enough. I've talked way too much, and so we will come back for a 3rd video for finding the area of polygons. Okay, so hopefully you learned something out of that. Come back for a 3rd one. It's going to be even harder.